Hello everyone, my name is James Pruitt. This is my fifth lecture on JavaScript. We're still continuing on a large integer data type. Um, Last time I left off, we were talking about the environment model and nested functions and closure. So let's get started with that right now. We had, if you remember, here's my program. We created a function var times function the parameter y, and it returns a function with parameter x such that return y times x. So when we did the var and we formed this new function called times 3, so and times 3 returns a function that multiplies 3 times x. So 777 gives 21 and 555 gives 15. So what we had, let's go ahead and write that again. Var times is equal to function y, and then it's going to be return function x, and that's going to be y times x. We can do so this is our function, and we said that when you call this is we're in a global environment right here. So when we call this function, function constructor, excuse me, when you call this function constructor, you create a value, a function value. So you have your global environment, E naught, that's our symbol for our global environment, and I said times, that var is a declaration which inputs the identifier times into our environment, and initialization, which is a separate, it's a declaration together with an assignment. So our store has our procedure, which points to the code. It doesn't get executed until you call the code. It points to the global environment because that's the environment that was there when you created it. So this times gets pointed to there. And so when you call times, when you do a function application, so you call, so we said var triple is equal to times 3, and so this is still in the global environment, so we put triple in here. That's the declaration, and then we'll have to do an assignment, and that's what initialization does. It does the declaration and the assignment together. So what we're going to do is we have our global environment. Times creates a new environment. When you do a function application creates a new environment, and we'll call that E1. And that points up to the old environment, which is E0. So if when you're in the function and it needs to look up a variable, it will look into this environment. If it finds it here, then it will use that value. If it doesn't find it here, it will look into the parent environment. So there's a hierarchy here. So what we did, we said times 3. So what it does is it looks up this function that we created, times, and it says this is the parameter y, and it adds y to our environment. Excuse me. It invites y to our environment, and then it takes this argument 3, which is in our value store, 3, and it maps y to that 3. So if I and then it executes that function, which that function is what is going to create this value here and return that value. So that return value is going to be assigned to triple right here. So what it does is, so this y right here gets assigned to 3. And so what we do, we want to create this new procedure. this new one, and that's the code, and that's y times x, return y times x. And then it has the new environment, which is E1. So, and then the triple gets pointed, then the triple gets mapped to that new, that new procedure with the E1. And this new code is this internal procedure right here, right? This right here. This is the code. If I call var double, now I've already had the double before, and I said times 2, and when I apply this function again, it creates a brand new environment. It doesn't reuse any old environment. It creates, and we'll call this E2, and that environment points to the global environment E0. So when we're executing the function, if it needs to find a variable, it looks in the E2. If it can't find it, it will go up to its parent, which is E0. And then it assigns y to this is a value store. This is and assigns 2 to y to 2, and then it executes the function, which the function code just creates a new function. So this new function, so when it executes that, it creates another function, and we call this double, and it creates another function, and it points to the code, whatever it is, and then it has an environment. This is a different environment, so E2 and E1 are different. Every time when you apply a function, it creates a brand new environment. So that environment is different from every other one. So that's what's called closure, and this process is called closure. And again, it's called closure. And again, the authors of the structure and interpretation book, they don't like that term, but it's so common, we have to use it. Let's see, where am I at? Okay, now we have an idea of how we're going to. That's a mechanism of abstraction. We had our 3 things. What are the primitives? What are the means of combination? What are the means of abstraction? That's one of the means of abstraction for JavaScript. So we're going to use that means of abstraction to construct we're trying to construct a large integer type, and we said our integer is going to be an array. This is our symbol, and this is our constructor for an array in JavaScript, and it's going to look something like this: A0, A1, A2, A3. Right? This is where A3, where the number is A3 times 2 to the 26 cubed plus A2 2 to the 26 squared plus A1 times 2 to the 26 plus A0. So this is how we're going to represent a number, but we want it to be constant. We want it to be, once we've constructed it, we don't want anybody to have access to it. So we're going to use this process of closure. So if you go to my website, let's move this back down here. If you go to my website at pruittmath.com, www.pruittmath.com, you can come over here to the right, and you can look up JavaScript or computer algebra. My website's still under construction, so you have to forgive me. I'm still learning HTML and JavaScript and CSS. So here it is, and you can come over. Once you come over to JavaScript or the computer algebra, you can pull up this integer.js, and then you can save it to your computer. And we're going to work through this. I've already tested it, and it seems to be working all right. And when I construct, I download this to my computer, and I use Vim or GVim for for Windows, and I go ahead and download it to my hard drive, and now I got it here on GVim, my text editor that I'm using. So when I construct a new data type, the first thing I do is I want to have a constructor that converts a string to my starts off as input constructor with a string, and then I want a print function that prints it out in string format, so that way I can test. I can input stuff and I can output to see if everything's okay. So I want to be able to convert my data type to a string, and I want to be able to construct from a string. So that's what we're going to do. We're going to have our initializer, and it's going to be a function. So I'm going to use this closure property. I'm going to use the closure property to abstract away to make my integer constant, to prevent someone from having access to it. So when you call this integer, which creates an integer, and the initializer, and you have the input as initializer, it creates a new environment, and it stores this stuff in a new environment. So down here I'm going to create another function, and that's going to be this second function. So my integer is going to be a function. So my second function will be bound to this environment. So every time I call it, it gets a new environment. And all this data is secure, that nobody from the outside can get access. Only the function down here has access to these variables. So let's go ahead and let me go back 1 second, real quick. Let me pull this up here. I want to say one thing. This y right here, if you look at this code, this function, from function to this semicolon right here, y is what's called a free variable, because you can't change within this line. You can't change the name of y. You can't change that to z and it still mean the same thing. But this x, on the other hand, from function to semicolon, is called a bound variable. And you can change that name everywhere you see an x in this line, and it's still going to be the same thing. So it could be function z, return y times z, and you still get the same value. So x is called bound variables, and y is called free variables. And the bound variables you don't have to worry about, but the free variables, that's why it's connecting the environment to it, so it knows where to look up for its free variables. So it will look up into the environment that it's bound once you create it, that environment we talked about, to find its free variables. Okay, that's what I wanted to say. Let's get back to our going over our integer. So here's our hidden variables that's going to be unable to be accessed from the outside. Only my integer data type, integer, has access to it. And we start off with the radix, and I said it's the power. This is the math. This is the math object, and this is a function in the math object, and it takes 2 and raises it to 26, and that gives us our radix. Our number is right now it's just going to be an array. That's a constructor for an array. And then a negative, and if it's false, that means it's positive. If negative is true, that means it's negative. That's how we're going to record negative. It's a boolean. These are booleans, and it's either true or false. Okay, then these are just my temporary variables for constructing. Okay, the first thing I want to do is I want to construct. So I want to fill in this number to the array of my numbers. And all these numbers in my array are going to be less than 2 to the 26, less than my radix. So the first case is just a regular number, right? And that's my IEEE 754 format, my floating point, 64-bit floating point number. So I'm running out of time, so I'll pick up there next time. Okay, bye.